Okay, so here's some examples of when we're asked to factor completely, what that really means. So for 16, we would factor it and we would normally say, oh, that's 2 times 8. But then 8 can still be factored, so you have to keep going. 8 is 2 times 4, and then 4 can still be factored, and 4 is 2 times 2. So when we do the factoring of 16 completely, we know that it's 2 times 2 times 2 times 2. Okay, so we can't stop here because we know that we can keep going with 8, and we can't stop here because we know we can keep going with 4. We have to get all the way down all of the factors of 16. So something like this, if we were asked to factor this, we have to pull out the greatest common factor. So we could pull out a 2 from both sides. If we take a 2 out of this one, it's like we're dividing by 2 and what's left is x squared. And if we take a 2 out of this one, it's like we're dividing by 2. So 4 divided by 2 is 2, so it's a 2x. But this still isn't factored completely because both of these still have an x in them. So now you have to pull out an x from both parts. So 2 times x, and then when you pull out an x here, you have one x left, and when you pull out an x here, you have a 2 left. So you have to keep going until there's nothing left that could be factored out. There's no common factor in what is added together in the parentheses. So here, when we want to factor this one, we need to start. There's a 4 in front and an x squared. There's an x here, but there's no x over here, so we can't take an x out. But a 4 and a 10 and a 4 can all have a 2 come out. So we need to take that out, and it's easiest to do it first. You can do it at the end after you have two sets of parentheses. You would see that there's still a common factor, and you can take it out then, but I think it's easier to take it out first. So if we do, if a 2 comes out, we're left with 4 divided by 2 would be 2x squared. 10 divided by 2 is 5x. And this 4 divided by the 2, see, is 2. So what we're doing here, it's like the reverse of distributing. If I want to get back to the original equation, I could multiply this 2 here and here and here, and I would come back to the original equation. So in algebra, we're going to be going both ways. We're going to be factoring, or we'll be distributing and putting it back into this form. In this case, we're pulling everything apart, so we're taking everything that we can out. The greatest common factor here was the 2. So now we need to take this and factor with our parentheses sets. So we leave that 2 out in front because you factored it out. It's a factor, so it's going to be multiplied by stuff. So you can just leave it out in front right next to parentheses set. And then we have this one. We have a 2x here, so the only way that you can factor the 2x squared is just a 2x and an x. The only way that we can factor 2 is a 2 and a 1. So at least we only have 2 choices here. So I'm going to start by putting our only 2 factors of this at the front of the parentheses. So we have a 2x and we have an x. It's all pluses. Now I got to figure out, do I put the 2 here or do I put the 2 here? So if I put the 2 here and the 1 here, my OI would be 2x times 1 and 2 times x. So 2x times 1 would be 2x and 2 times x would be 2x, and we add that together and that's only 4. So that's not correct. So we're going to go back to where we did it and we'll put the 2 in the other spot. Okay, so now if we put the 2 in this spot and the 1 here, when we do our OI part, we have 4x and 1x, and that does give us the 5x that we were looking for right here. So just to show you that it does all work out here, when you're trying to double check, we would put, you can do it either way. You can distribute this first and then FOIL, or you can FOIL and then distribute a 2 across. I'll just show you what it looks like. If you were to distribute this 2, just do it to one other factor. You don't multiply it by everything. Just like if we have 2 times 2 times 2. We would multiply these two together and say, well, that's 4, and then we would multiply 4 times this 2 and say the whole thing is equal to 8. We wouldn't take this 2 and multiply it by both of them and say, okay, well, now we have 4 times 4, and that's 16. That wouldn't work. So when all of these are multiplied together, when you're distributing, you just take this and multiply it by one set of parentheses, one other factor. So if we do this here, 2 times 2x is 4x, and then 2 times 1 is 2. Now this is still a factor, so we put it in parentheses with this factor over here of x plus 2. Now we can FOIL. So the first ones are 4x squared. The outside is 2 times 4x, so that's going to be 8x. The inside is going to be 2x. And the last ones are going to be 2 times 2, which is 4. So then 4x squared plus 10x plus 4. So this is our original equation. So I think part of the question was, why can't we just factor it like if we had factored it to here? And that's because it's not completely factored. If you're looking at your two factors, your two sets of parentheses, and you see that in one of them you have a 4x and a 2, you would see that there's a GCF, there's a greatest common factor here that could be taken out. Both the 4 and the 2 have a factor of 2. So if you did factor it here, then you could take your 2 back out to get the completely factored version up here. So you always need to be looking. I think it's easier to take it out first, so look up here and see, oh, all of these are divisible by 2, so I can take a factor of 2 out. But if you do factor 2 sets of parentheses and then you look at one set and realize that there's a factor there that could be taken out, you could take it out at this point and get up to this as your final completely factored answer. Okay, hopefully that helps, and I'll see you on Monday.